If you're a data scientist or researcher, you have been here, so your Python script works perfectly on your machine, but when your colleague tries to run it, everything breaks or works worse. You can't even get to run your script inside like your fabulous cluster with many GPUs, and this is very frustrating because there is like dependency crashes, and this phase is called dependency here, and it's one of the biggest roadblock to reversible science. But what if I could like give you a solution that could like package your entire uh, local environment based on Conda. So you can grab every Python library and even the system level dependency if you work on Linux, any kind of pip and any kind of apt packages that you install could be present inside a single file which is portable and that can be run everywhere. And that's where Apptainers come in. And in this video, we will talk about Apptainer and Singularity more in details. And what is Apptainer? So Apptainer is, which maybe you know by its former name is Singularity. Uh, and Singularity is basically a container platform built specifically for scientific and high performance computing. And the key characteristics about Apptainer and Singularity. So in this video, I will switch a lot with Apptainer and Singularity. So anytime you see the command line Singularity or Apptainer, it's basically the same. They, they, it is simply a matter of name. That's it. So the key characteristic are this is focus on security. So there is no root privilege needed to run everything that's inside the image. It's optimized for high performance computing. So you can run your script in a big cluster with many GPU, or many GPUs, like a cluster with like hundreds of GPUs, like in your dreams, and with like also like with a lot of CPUs. Also, it's based on a one single file, so the entire environment is just like bundled into one zip file, and that's make it very easy to share and distribute, and it is perfect for Python and Conda environment if you want to share or work into like your data science workflow. And why should we containerize this? We previously mentioned the edX about like sharing codes, but what we want to do is we want to make sure that our approach and code that we develop is reproducible. So this workflow and this method allow us to develop and ensure that our research can be replicated exactly the way we did and can be replicated uh, anywhere, basically. The second thing is that if one day you have access to billions of cluster, you want to be able to run it the most efficient way, and this is the most efficient way. Also, this will, as like it's done on in Docker, but Docker is not very optimized for GPU computing. It will package everything from the Conda environment to the local dependency. So it's very great for managing all the dependency. And last but not the least, it's very easy to share. So it's very portable. It's just contain single. The image is just a simple file with the CIF extension. So you can have it like on your PC, on your laptop, on the cluster. It's very the experience is the same, seamless. So very this point is also something that is very interesting about like the containerization of all scientific work. And now let's discuss about how do we create such things. So This is basically a recipe that is used to create a Singularity image. It's very similar to Docker if you already used it. It's basically the first two lines tells us from where we want to take the image, the base image, from where it will be based on. The second part of the file is just like some parts that are used for either like making some copy. In the post, you can build instruction. In the environment, like it's mentioned, you can define a environment variables, and run script basically can allow you to run a specific command each time you run the image. So now I will like be give you more details on it. So basically the structures, as I mentioned, is like this, but here the two first line is from which um, from which hub we want to take the image, and most of the time you take from Docker, and then from like in Docker you just have the name of the image. And in our case, if we want to build an Anaconda environment that is ready for our data science and deep learning, sorry, deep learning stuffs, this is very good because it contains already Python and Conda install. It's very minimal footprint, and it's also since it is an official image, it is regularly updated from Anaconda. So this is a best practice if you wanna like you have like a Python environment with Conda in it inside it, and you wanna create a sieve. This is the base image to use. Um, in our case, if we want to create an Anaconda environment, the best strategy to do is will be to copy not the requirement.txt but configuration YAML file that I will show you how to create, and copy it inside OPT and copy it like so. And basically the Conda environment file look like this, and we show you later on how to create this. And basically from every environment you can have like some kind of a signature of your environment with like the channel, the dependency, and the pip packages if there is any. In the post, what you do typically is you install things uh, once the image is built. For example, in our case, what we want once the image is installed, we want to create a Conda environment inside it. So that's basically what we do. And also what we want to do is most of the time we want to clean things that were not used. So cleaning is very important, as we mentioned, because everything is saved in one file, and the file can become like big in no time if we do not make sure that everything that is needed is inside it. And the two last parts are coming from the section environment, when we basically like set uh, environment variables for the complete session for the image. Can be anything, and in our case it will be the environment name and the path of the Anaconda, which will allow us to automatically run and activate our environment. And lastly will be the run script section, and it will allow us to execute and this command, which is basically used for activating the actual Conda environment. So every time we run something inside the Singularity image, this command will be run, and if run Python inside, will be sure to be inside the correct environment for a Python script. And now I will show you how to build the image, and it's very simple. So the command is sudo Apptainer, also do Singularity. It's pretty much the same as I mentioned. Build followed by the name of the CIF file that you want to give. So it could be my Anaconda app, it can be my app, it can be my.env.cif, and based on the Singularity recipe file. So that's basically all the command is written. So every time there is like Apptainer build, the name of the thing that you want to build, and it's based either on a sandbox or a recipe. That's in our case it's a recipe, but later on I will show that it can be also created from a sandbox. And a sandbox is basically a local directory that is that simulate your full images that we will see later on. And in the building process inside the recipe, so first we download the base image from Miniconda 3. We copy the conda file into PT. We create the conda environment. We set up runtime variables, environment variable, and at the end we have like our single file.cif created, which is pretty nice. It was very easy, and this will be very easy if um, in your Conda environment, everything is installed in Conda. This pipeline will not fail if your everything is installed with Conda. Sometimes if you have like pip packages and you extract your YAML inside it, there is like pip packages, it might, for some weird reasons, a pip doing something weird sometimes. Some packages might provide like errors. So I will show you like a way to go over this. And yeah, so in this example now, if you want to add new packages, but they are not like based on pip, they're not based on Conda, but the only distribution is from the package manager pip, and the actual pipeline is to create a sandbox from the Singularity file. And as I mentioned earlier, a sandbox is basically a directory that represents your image with everything inside it. It's like a mini operating system with everything inside it, and it represents your Singularity image. And inside it, you can do all kind of modification that you want. You can access it from the shell, and you can access it directly from uh, the directly with file management. And it's useful for two reasons. If you want to change source code of Python libraries, for example, or if you want to, as I mentioned, if you want to install some new pip packages. And the method is based on sandbox. So I will show you how we create this now. And there is three methods to do this. The first one is like, as I mentioned, create the sandbox from the Singularity image, connect it with a shell, do some things, do your thing, do your pip, etc., etc. The other thing is updating the YAML, but most of the time, uh, uh, if in your YAML you were lucky and the pip packages were working fine, so the first step is not required. So everything is clear, it's great. But if in the first step, when you add like your conda environment and your pip environment inside the conda env YAML, and it was giving you mistakes, errors, you need to like do the first step. And in either way, you with the sandbox be able to edit source code. And in the second video that I will make showing you all the full pipeline in live session, I will do the sandbox and modify, for example, scikit-learn or any library that I wish to modify, and I will show you like basically how to do it. So to create the sandbox, basically what you do is Apptainer build the tag sandbox, the name of the sandbox. Basically, instead of being Singularity image .cif, it's like the actual name of the directory, as I mentioned. and it's based not on the recipe, but this time on the Singularity image that we built. And then, as I mentioned, we can access it with shell, and it's just Apptainer shell that are writable to make sure that everything that we do inside it with the shell will be saved inside the sandbox. And if you want to install new packages, that's basically the pipeline. You do this, and then once you're inside the shell, this command line is the magic. If you do not do this, the full pipeline will not work. The full pip install and conda activate will not work. So this will allow you to initiate the conda bash, so you can run any conda comment. So do not forget to use this because it's very very important. So once you do this inside the shell, you can then conda activate your environment, and then you can check everything that you want based on conda, and then you can install the package that is missing. And once it's done, you exit the container and you rebuild the image using Apptainer build data of new, for example, .cif, based this time not on the recipe file but on the sandbox. The third approach is when we want to edit Python library in source mode. So what we have is we, as previously, we need to be either on the shell, we can modify it on the shell, or we can modify it directly from file. So we can do the shell and we activate the environment the same way. Always need to do this when we are on the shell. And for example, if we want to locate the where is scikit-learn, we just Python import this with the init, and this will give us the path of the scikit of where scikit-learn is located. And then, as I mentioned, when we create the sandbox, we'll be able to go directly into OPT conda on data of Python 3.9 set packages in scikit-learn. And inside this scikit-learn, there will be all the Python file associated to the scikit-learn packages. And inside it, you can do whatever you want. You can change function, make sure that you do not mess up with the full library, but if you need to change a specific function, you can. And yeah, so in this case, we basically change the by hand, but it can be changed with the directly with the repo that uh, will be created by the sandbox. And the other thing is rebuilding everything, but directly with the environment file. So the environment file will your environment file with your conda environment will probably look like this. And you can also add the pip packages, but as I mentioned earlier, sometimes depending on the pip version that you have, some packages when you install this with not the correct version, they give you some dependency or some not available packages. So yeah, if this is working perfectly for you, it's fine, but know that sometimes some pip packages can get you can give you some headache. So yeah, just build them, go back to method one, and just create your sandbox, install your pip file, pip and pip packages, and you'll be rebuild, and you'll be fine. It's not that much big of a deal. It's pretty straightforward. Yeah. This is the easiest way. If everything works fine, you just have to rebuild things directly from the updated environment file. That's it. But what you do is the first thing that I mentioned based on the recipe, and you just update the environment file. But From my experience, you will see that once you have like a lot of like pip packages, it is most likely that some of them will cause an issue. So it is safe to like make sure to be able to do the first approach. So making sure that you know to create a sandbox, connect it with a shell with the writable tag, and then do something inside it. Install pip. You can also install Linux packages, and then once you're done, you close the shell and you rebuild, and that's it. That's very straightforward. And once your package, once your image is done, it's cleared, you can execute code directly from it. So the what to execute code is basically Singularity or Apptainer exec the name of your Singularity file, followed by a command line. In this case, it's Python, my script, for example. We can also like have like some interactive session. We can also use Jupyter Notebook. It's very straightforward to do all of this. We can also have like access to a shell to have like an interactive session with the shell. So Apptainer shell followed by the name of the Singularity image. So that's it for the command line that you basically need to know. And now we will like summarize the best practice that you need to follow once you do this uh, in production or in your local development inside your, for example, during your PhD or during your research. So the best practice concerning version control is like to make sure that the YAML file and the recipe are tracked and that any version is correctly specified with a tag. So you make sure that if you messed up something, you can go back to the previous working version. Also, we mentioned this briefly, but make sure to only put inside your code or inside the image the thing that you are all using. I didn't show this, but I will show you in the next video. You do not usually copy data or code inside your Singularity image. Usually bind like you do in Docker. So make sure to not like copy unnecessary things inside your image and delete like any file that will not be used. Also, avoid like for security like best practices, avoid to use root access and use as much as possible official base images that are trusted from trusted sources, for example, Docker, the Docker hub, and also try to update uh, your your base images as much as you can, like that follow your cycle of development in your local machine. And why this approach is works and what is you should use it are for the following reason. So first, it allows you to like uh, make sure that your science is reproducible, so you can run the exact same code anywhere, anytime. So that's the beauty of it. It's very fast. It's just a single file. It can be transferred anywhere, and it can run anywhere. If of course there is singularity inside in the machine. Also, the, well, Jim mentioned this, but it is specifically defined and optimized for running in HPC. So it also do not require cluster like not require root privilege. So do not have like any chance to mess up with like your cluster. So your administrator will not like will not get to you. So it's pretty safe. And the last thing is it's like make sure that this your code can be shared to everyone, and the collaboration can be seamlessly like between can be done between colleagues like in a very easy manner. You can have like anyone run your code once you have your complete environment set up with Singularity. So that's it for the video. So try to give this like a try for your project. And if you find this helpful, do not forget to like and subscribe to this, and like leave a comment to let me know if you are using like a container in your research and what type of workflow are you using. And thank you for watching, and see you in the next video for the presentation of the live session to create the actual Singularity image. Bye guys.